Hey guys, welcome to lesson 5 of GCSE Geography. We're going to continue focusing on water, and we're focusing particularly today on processes that go on within the river channel and how those processes create different shapes and landforms. So what we're aiming to do over the course of this lesson is construct the meaning for some more key terms using prior knowledge. We're going to be using words like erosion, things that you have come across before. And we're going to apply the understanding of these processes to the creation of fluvial landforms. A fluvial landform is just the proper way of saying a river landform. And a landform is a shape created by the river. So in this case, we're going to look at landforms in different stages of the river's course. The course is the path that the river takes, and it's split into 3 parts: the upper course, the middle course, and the lower course. And you tend to find certain landforms in different parts of the course. You tend to get waterfalls in the upper course, meanders in the middle course, and deltas in the lower course. So that's what we're going to deal with today, is what processes go on and how do they form waterfalls, meanders, and deltas. So when you're ready, go ahead and put the title, River Processes and Landforms, and we'll get started. Okay, so fluvial processes, river processes. These are the categories of processes we're going to be looking at. You've got erosion processes. Now erosion, you might remember we did erosion and weathering back in year 8 when you did that little investigation into how rock type and time affect the rates of weathering, when we went up the graveyard and you collected all that data on the geology of the gravestones. So if you remember, erosion is the wearing away, but crucially the removal of material. If something's just worn away and a chunk of rock falls off but it stays there, that's weathering. If it's blown away, washed away, carried away in some form, then it's erosion. The material that's eroded then gets transported, it gets moved. That's what it makes it erosion, okay? And the way that a river moves the material that it's eroded, it happens in 4 different ways that we'll look at in a minute. It then gets dropped when the river can't carry it, when the river can't transport it anymore. And what goes on in the river is related to how fast it is flowing, and we call that the velocity. All right, so you need to write down these 4 definitions into your books. So pause the video here and do that now, please. Okay, so we're going to focus on the erosion processes first. There's 4 of them. Now, you might remember a little bit of this from year 8 again when we looked at coastal landforms. You might have done the coastal kung fu panda dance to Everybody is Kung Fu Fighting, and we made up actions to help you remember the 4 types of erosion. Or maybe not, depending on who your teacher was. But if you were in my class, we probably did, because we do random stuff like that. So put a subheading, erosion processes. Now you're going to hear me talking about the river's load. The load is the material that the river is carrying. So it could be really fine sand, it could be great big boulders, it could be anything in between. All right. Now the river gets that load through 4 different processes, through 4 erosion processes. So it either wears it away using the force of the water in the river itself, which is called hydraulic action. Begins with the word hydra, meaning water. So this is the force of the water itself. The water squeezes into cracks, compressing the air ahead of it and forcing the rock apart. It might also erode from the river bed and banks. So the bed is the bottom of the river, the banks is the side, through abrasion. So this is kind of like a sandpaper action where the material in the river rubs against the side and the bottom and wears away even more material. You've also got solution. So the water in the river might be slightly acidic or slightly alkaline, and this might dissolve the soil or the rock around the edges, particularly in areas where the geology is quite soft, so maybe limestone or chalk areas. And finally, through attrition. So this is where the pebbles or rocks within the river crash into each other and break down into smaller pieces. So put the subheading erosion processes. You might want to put down the meaning of load as well, but definitely put down these 4 definitions. It's times like these that you might, if you have highlighters, if you wish to, want to highlight the actual term to make them stand out. So pause the video and go down and get those definitions down now, please. Okay, so once all the load has been created, once it's been worn away from the sides and the bottom, the banks and the bed of the river then moves it. It transports that material, and it does this through 4 different processes. So these are the transport processes. So put a subheading, transport processes. Now, the material that the river is able to move is directly linked to the river's velocity. The faster the river is flowing, the more energy it has, therefore the larger the load it will be able to transport. If the river's got quite a lot of energy, it might be able to move really large material. If the river's flowing much more slowly, it's going to struggle to move large material. Things rolling along the bottom, that's called traction. If it's kind of bouncing along the bed, along the bottom, that's called saltation. Really fine sand particles and things like that will be carried in suspension. And if something's been dissolved, then it's in solution. So underneath this subheading in your books, write down that subheading, then make a little version of this diagram for yourself, please. So pause the video and go ahead and do that now. Okay, so the material gets eroded, it then gets transported. If the river slows down, so the velocity drops, that means the energy that the river has to move its load will also decrease. So it will start to drop stuff. It can't carry it, it can't transport it anymore. And the proper word for that is deposition. The load a river can carry is determined by how much energy it has, how fast the water is flowing. If the river's velocity drops, the energy drops, it's going to drop everything that it's carrying. Now, there aren't different types of deposition in this case, it's just deposition is deposition. But if you'd like to go ahead and write down that little sentence or two, then by all means do so. Okay, so that takes care of the first aim. We're sort of a little bit familiar already with erosion from year 8, so we've activated our prior knowledge there, and we've introduced the idea of transport processes and deposition. Now, the second aim was to apply understanding of these processes to how they create landforms at different stages in a river's course. Now, I mentioned that a river has 3 stages, upper, middle and lower course. Now, the energy that the river has in each course is different, and it's very simply linked to gravity. Gravity is going to be acting more strongly up here, pulling the water downhill because the slope is much steeper. So the water is flowing much, much faster up here. It has a higher velocity. And that means that the type of erosion that's going on, it tends to be eroding directly downwards more than sideways at all. We call that vertical erosion. So in the upper course, what you tend to get are quite narrow valleys that have very steep sides. And the load tends to be quite large rocks because the river has more energy up here. As you come into the middle course, the river is starting to level out a little bit. So gravity isn't acting as strongly on the water. So you will still have some vertical erosion, but now you've got some vertical erosion still here, causing the river to become deeper. But what's starting to creep in is sideways erosion. We call that lateral erosion. And where these two are kind of both happening, the river starts to widen out a little bit and starts to sort of bend back and forth. We call that a meander. The bed load here tends to start to be smaller pebbles. They're smoother and more rounded as more erosion is taking place. And the sides of the valleys might be sloping a little bit more gently because the downwards erosion isn't as aggressive as in the upper course. So you get meanders and oxbow lakes in this middle area here. You get things like waterfalls and gorges and vertical features up here. Finally, in the lower course, you can see the land is almost completely flat where it comes to the mouth of the river, if you remember key terms from last lesson, as it reaches the sea or the ocean. And so in the lower course, we've got very little gravity actually acting anymore. So vertical erosion pretty much stops at this point. The river doesn't really get any deeper. What takes over is the lateral, the sideways erosion. So the river tends to get wider rather than deeper in the lower course. So you end up here with really fine particles, really smooth, small particles of river's load, and it creates estuaries and deltas. You've got a copy of this diagram in the worksheet attached to this lesson, so cut it out and stick it in. I thought I'd be kind to you rather than make you do too much drawing after last lesson. Okay, so cut it out and stick it down. Pause the video here a moment to do that. Okay, so what we're going to do now is course element by course element. So first upper, then middle, then lower. Look at how the processes of erosion, transportation and deposition create different landforms, different shapes. So in the upper course, we're going to look at how it creates waterfalls and gorges. In the middle course, we're going to break down how it creates meanders and oxbow lakes. And in the lower course, we're going to break down how it creates estuaries and deltas. So I'm going to start with the upper course first of all. Lots of vertical erosion, no sideways erosion, lots of fast-flowing water. So put a subheading, landforms of the upper course, waterfalls and gorges. You might recognise this image, in fact. This is of the waterfall in Pontarddulais Woods. And this is typical of how many waterfalls are created. There are different ways that waterfalls are created. Sometimes it could be due to something called isostatic rebound after an ice age. Sometimes it could be due to tectonic uplift after some earthquake activity or something like that. But most commonly, as is the case in Pontarddulais, a waterfall is a geological formation. Geology is the study of rock types. So waterfalls are created where different rock types exist in the same area. In this case, hard rock and soft rock. Okay, so if we break that down, here's a series of diagrams that show you in cross-section, so sideways on, how a waterfall is created. Now the diagrams are in the correct order, the annotations are not. You have this series of diagrams on the sheet attached to this lesson. So I'm going to explain what's going on in each one, and then using my explanation, what I'd like you to do is cut and stick this strip of diagrams across a page in your book and unjumble these annotations to write the correct annotation under each diagram to explain what's happening in the picture. So, the very start of a waterfall, a river will be flowing over the Earth's surface, minding its own business, and it will be flowing over harder, resistant rock, and it might reach an area of softer, less resistant rock, which is far easier to erode. So it will start to wear that rock away. It will start to erode it through processes like hydraulic action and abrasion that we talked about earlier, and that begins to create a little drop. As that erosion continues, it forms at the bottom of the drop something called a plunge pool. And that plunge pool, the water's sort of tumbling in like a little washing machine kind of motion around in here. And what that does is it erodes backwards as well as forwards. And that backward erosion undercuts the overlying hard rock and it creates an overhang. Eventually, because that overhang is unsupported, that overhang will collapse into the plunge pool beneath, and all this extra broken rock material will accelerate rates of erosion using abrasion in here, and it will deepen the plunge pool even further. That's why quite often it's perfectly safe to jump off of waterfalls, because you've got this super deep plunge pool on the other side. Just check before you do so that there hasn't been a recent collapse and there's massive boulders in here. But usually, yeah, that's why it's safe to jump off of waterfalls, because of the plunge pools beneath. This process of undercutting to create an overhang that collapses and then undercutting to create an overhang that collapses, it will repeat itself, collapse after collapse after collapse after collapse. And essentially what that does is the edge of the waterfall moves backwards, it retreats. And that creates a really steep-sided gorge running along here. Okay? So go back and listen to that again, or pause the video here, stick this strip of images down, they are already in the right order, and unjumble these annotations underneath, writing them under the pictures in your book to explain the process of waterfall formation. Pause the video here and do that now, please. Okay, so this is the correct order, just for you to check. All right, so that's what's going on in the upper course. The river has a lot of gravitational potential, a lot of energy, a lot of vertical erosion going on. So it creates waterfalls, large boulders. The load is quite big up in this area of the river's course. That just sort of explains the feedback loop that I touched on in the last diagram, where the hard rock gets undercut, it creates the plunge pool that deepens, the hard rock collapses, the waterfall retreats to create a gorge, and then more soft rock is worn away, and that kind of collapse of overhang and retreat of the waterfall creates the gorge in this repeating feedback loop. So if we move on from the upper course to the middle course now, because the river is starting to level out a little bit, you've still got some vertical erosion. There's still a gradient here that means that gravity is still causing downwards erosion, but not as strongly. So what starts to happen is lateral, sideways erosion starts to kick in, and that causes the river to meander. So landforms of the middle course, put this subheading down please, meanders and oxbow lakes. And here's some photographs of what it is that we're going to break down the formation of. So you can see the river's course here, and it's starting to bend and snake back and forth. The bend in a river, that is the meander. Okay. Now, have you ever, on the school bus when you're going around a corner, especially if you're sitting on the back row, whichever way the road is bending, you all kind of squash the person on the outside of the row up against the window on the outside of the bend? It's hard to explain without us being in a classroom together, and you can see my usual hand talking going on, but it's the same feeling that you feel when you go around the bend in a car or anything like that. You feel kind of a little bit pushed to the outside of that bend. That force is called centrifugal force. And what that does to water in a river is it causes it to flow much more quickly around the outside of a bend than it does around the inside. Now, I mentioned to you before that when the river has a higher velocity, it has more energy. And energy means erosion. So what happens on a meander is around the outside of the bend, the water is flowing far more quickly, because of that centrifugal force that I was just talking about. And that erodes the bank on the outside and creates a really steep edge called a river cliff. It looks like this. Meanwhile, on the inside of the bend, the water is flowing much more slowly all the way around here. And because the velocity is lower, the speed of the water is lower, the river doesn't have as much energy. So it drops the material that it's carrying. Deposition happens all along the inside of the bend here, look. And that creates a river cliff or slip-off slope. You might hear both terms being used. All right. So essentially what's happening is the inside of the meander bend is getting filled up with new material, and the outside of the bend, if you could see the edge of this image, the outside of the bend is being worn away. So what actually happens is the path of the meander shifts sideways and changes and migrates. And sometimes what happens is, as you can see here, erosion going on the outside there and on the outside there. Sometimes the gap between the two meanders gets very, very narrow. That's called a meander neck. Eventually, what do you think will happen? Perhaps next time the river floods, when it's got a lot of energy, it's going to cut through there. And the river will then take a new path straight across here, leaving this area cut off. That's called an oxbow lake. You can see that that's what's happened here. Originally, this river would have come around here, come in here, through there, and back out there. And there would have been a meander neck here, like there is here. But the river has cut straight through, leaving this old part of the meander isolated. It's called an oxbow lake. Sometimes over time that might all evaporate, but it's full of lots of really fertile mud and sand. So this, quite often then, if it dries out, you'll get vegetation growing in here. And it'll create what's called a meander scar. Now that's a lot of information I've just thrown at you there. In the folder attached to this lesson, there's a little flash animation of how a meander forms. Hopefully if you've got Flash Player on your computer, you can load it. If not, if you type meander formation animation into Google or into YouTube, you'll find videos that might help you visualize what it is I've just explained. I've also given you a breakdown diagram on the sheet that accompanies this lesson, but it's very common that a really high marking question crops up that says, explain the formation of a river landform, use diagrams if you wish. It happened for waterfalls before, so just in case it happens for meanders, it was worth 6 marks when it cropped up for waterfalls. I think it was last summer. Just in case it crops up for meanders, the diagram that I put on your worksheet only has a couple of really basic labels on it. It's got those 4 on there already. So just in case you needed to explain the formation of meanders in more detail to try and get 6 marks in an exam, I've added a couple more annotations, these 4, that I would also like you to add to yours in your book. Okay, so cut this diagram off of the worksheet that goes with this lesson, stick it down in your book, but stick it down in such a way that you've got room to add these 1, 2, 3, 4 extra annotations around it, just to cover our back, so you've got plenty of detail there if it pops up in an exam. So pause the video and go ahead and do that now, please. Okay, imagine we cut down through the land along this cross section from X to Y, and we were looking at it sideways on. All right, so you've got deposition, river beach on the inside, erosion, river cliff on the outside. This is what it would look like in cross section. Okay, this also popped up in an exam before. It's only worth 4 marks though. That's still quite a few marks for a relatively simple question, but a surprising number of you guys struggled with this. So what I'd like you to do is, with very little guidance from me, you should be able to, I'm hoping, match these annotations, well, these labels, they're a bit more basic, to each of these boxes. That's exactly what they asked you to do in the exam. They gave you this diagram and asked you to match. It was only 3 labels in the exam, but still match the labels to the correct points on the diagram. And surprising, like I said, a surprising number of you found it really tricky. So, could you draw this, please? I've tried to limit the printing. Draw this out. It's a fairly simple one. And then match these labels to the correct box. Okay, so pause the video and go ahead and do that now, please. Okay, so here is a better visualization of what it is we've just explained. You can see here, look, a perfect example of a meander scar, where the river originally would have come across here and through here and then down there, and there was a meander neck here. The river has cut through. That would have originally been filled with water, an oxbow lake, and over time it's dried up and vegetation has grown in it and created a meander scar. You can see another meander scar over here, another meander scar over here, and here actually is a perfect example of an oxbow lake that's in the process of drying out to become a meander scar. Okay. So it's all linked to the speed that the river is flowing. Faster on the outside, erosion, slower on the inside, deposition. The balance of that erosion and deposition causes the river to move all over its floodplain, and where parts of the river get cut off, it creates an oxbow lake that eventually dries out to form a meander scar. Okay? Okay, last part then. So moving on to the lower course. So the land has pretty much flattened out here. So the gravity isn't really acting so strongly to continue vertical erosion. Rivers don't really get especially deep in this part of their course. They tend to get far, far wider because it's pretty much only sideways erosion now. Little to no vertical erosion at all. And what that creates is estuaries and deltas. Okay, so put a subheading, landforms of the lower course, estuaries and deltas. Okay, this is what an estuary looks like. We've got loads around by us. The Locher estuary is a perfect example just down the road, where the river has come down to meet the sea/ocean. There's your mouth, and you can see here there's lots of deposition going on. The river has very little energy at this point. It's not flowing very fast at all because the land is so flat. Very low velocity, very low energy, very high deposition. And that creates lots and lots of muddy areas around the river. That is your estuary. Now, in some cases, the mouth of the river is much, much wider. And it fills up and fills up and fills up with all of this deposition. And it looks a little bit more like this. That's called a delta. It's like a massive triangle shaped area of new land, essentially, where deposition has built up so much over an extended period of time that it actually creates new land. And the river, to still get from where it's flowing to the sea/ocean, actually has to kind of split into lots of mini rivers to cross the new delta that it's made. This splitting is actually called braiding. Okay. Now, deltas exist all over the world. The largest and best example is the Nile Delta. This huge triangle fan-shaped area of land here in northeastern Africa. Now, if I actually come out, I pressed escape then instead of F9, so I exited the recording instead of just pausing it to switch screens for a minute. So apologies for the slightly abrupt change there. But yeah, if I just come out of the PowerPoint for a moment and into Google Earth, as you can see here, this new version of Google Earth is really cool. You see all the stars and things in the background. Anyway, so as I was saying, the Nile Delta is one of the largest deltas in the world. It's so large, in fact, it's visible from space. So if we just get our bearings a minute, there's the UK. So there's us. It's Western Europe. If you come over here, come over the Mediterranean Sea, down to the continent of Africa. So you can see the Sahara Desert here. Congo rainforest in the centre here. The River Nile, the course of which comes all the way up here. And if we zoom in a bit, there you go, we can see the Nile Delta here. A huge triangle fan-shaped area of land there. It's so large, in fact, that actually 1/3 of Egypt's population live on it. And that is where we're going to leave it for today. We're going to pick up from here next lesson and look at the Nile Delta as an example of a depositional landform of the lower course of the River Nile. And we're going to look at it in particular in relation to how humans rely on this fluvial landform. It's a massive lifeline to the people of Egypt, but further back up the Nile, they've built a massive dam called the Aswan Dam. And it's affecting the delta all the way down here. So that's what we're going to look at next lesson. So hopefully today you've now got a better understanding of the 4 processes of erosion, the 4 processes of transportation, when and why a river might deposit its load due to a decrease in velocity, and how in the upper course waterfalls and gorges are created, how in the middle course meanders and oxbow lakes are created, and moving on to next lesson, how in the lower course estuaries and deltas are created. So that's what we'll move on to next, is a case study of the Nile Delta, how it's formed and how it's used by people. So that is the end of lesson 5. Rocketing through, doing really, really well. I totally understand this is a really tricky way of picking up brand new learning. So as usual, drop me an email if you have any questions, queries or concerns.